Hello, everybody, and welcome to another HMAA webinar. We're joined today by two speakers who are experts on beekeeping, Robert Brown and JP Sheerlinck. And interestingly, Robert's in Bangkok and JP, you were in Melbourne, I think.
No, I'm in Tasmania.
Victoria.
No.
Oh, you're in Tasmania, back in Tasmania. Good. And yes, we are going to hear from them in a second, and they've got a lovely introduction, so I'm not going to give you any more information. But let's keep going with beekeeping success. And Robert and JP are happy to have questions after the talk is over. Thanks, everyone. Robert, do you want to get started?
Okay. Thank you, Jennifer. Thank you, everybody, for inviting us to the talk today. And it's our absolute pleasure, myself and JP, to be here to talk and meet with you all and answer any questions later. So what we want to talk about initially is our recent book, Beekeeping Success, which I'll explain shortly. First of all, though, I'll go through a brief biography.
Robert, you need to share your screen.
Sorry?
You need to share your screen.
Oh, sorry.
Yeah, I can see it.
We can see his screen.
I can see it too.
Yeah. Maybe you need to change your view of the screen.
Yes, okay, you're good.
Yep.
Okay. Okay, everybody see it?
Yes.
Yep.
Okay. I have a PhD in the epidemiology of the mite varroa destructor from the University of Melbourne. And as you're aware, varroa destructor was discovered in New South Wales a few years ago and is now generally causing chaos across eastern Australia, just as it has caused chaos and destruction across North America, Europe, and much of the rest of the world in the past, say, 30 years. In my PhD, I was very fortunate to have JP as one of my supervisors, and he certainly helped me along a lot, and I learned a lot from JP. Around 2015, I wrote the book, The Australian Beekeeping Manual, which is very highly regarded and widely used within Australia. Subsequent to that, JP and myself and another professor wrote Honeybee Pests and Diseases, which is quite a comprehensive discussion of bee diseases, but aimed more at the commercial beekeepers or researchers. I've written extensively for Australian and North American beekeeping magazines, most notably the American Bee Journal, which is a very important magazine. But I've been writing science articles since about 1980. So I've a long background in writing. Probably the highlight of my career, the American government aid agency, USAID, which is now closed down. I've worked with them for 2 or 3 week stints, a few times in Nigeria, Benin, the country Georgia, Malawi, and other parts of Africa, Bangladesh, Nepal, and Lebanon. Unfortunately, Elon Musk closed down USAID a couple of years ago, but so that was a very interesting and useful, I feel, part of my life in learning about beekeeping. I also formed Bob's Beekeeping Supplies in Melbourne, but sold that when I moved to Thailand. So I'll pass you over to JP now.
Yeah. So I actually started as an amateur beekeeper, and while I was a professor at the University of Melbourne, it was in a different field, more biotechnology and immunology. But I had a passion for beekeeping. And as part of that, I founded the Melbourne Beekeeping Club, Bees at UniMelb, which later on morphed into the Melbourne Beekeepers Club. And it's now open to the public, not just to Melbourne University staff and students. In the beekeeping area, I have been working to try to set up a pollination security CRC. CRC is a cooperative research center, which is a very large research effort. And this one had 52 partners and a 10-year lifespan and about $100 million budget. I think it was very needed, but unfortunately it ended up not being funded. And more recently, I was a technical lead on the Wien Bee Foundation's Pollination Security Status Report. That report is being published now and is a lead to the pollination security strategy. And feedback for that is now being gathered by the Wien Bee Foundation. And as Robert mentioned, we co-authored a book together just after he completed his PhD about bee pests and diseases, which is more of a technical manual. Over to you, Bob.
Okay. Okay, thank you, JP. So the agenda today is I will discuss why write the Beekeeping Success book, the difference between commercial and hobby beekeepers, and getting started as a hobby beekeeper. JP will go on to discuss the status of crop pollination and the impact of the varroa mite on crops in Australia and globally. So I'll start and JP will continue to the end. So beginners have many questions about beekeeping. Many beekeepers go out and buy a book on it, like my Australian Beekeeping Manual. Other beekeepers focus more on internet access, Google, DeepSeek, ChatGPT, and so on. And they have advantages and disadvantages. Although manuals like mine cover beekeeping from A to Z, if you have a specific question about your hive, often a standard beekeeping book isn't the best place to go. So, for instance, if you have a concern about a particular disease in your hive, maybe a chapter on beekeeping diseases is too broad. You need to focus. You want to prefer a more focused question and answer. And my experience with Google and ChatGPT and other internet access is that quite often they give erroneous answers to questions. And my feeling is, unless you know what you're talking about to start with, you can be led astray by asking questions on the internet if you're not in a position to, validate those questions yourself for reasonableness. Okay. So we started looking at a new book, a new format. So instead of having a standard beekeeping book with chapters on everything, bee biology, then moving into what equipment to buy, and then my first hive and what to do in the spring and how to manage diseases, how to extract. We formed the book quite differently. We thought of all the possible questions that a new beekeeper might ask over the course of his or her hobby. Although the book is roughly split into chapters, the index is a series of many questions. So you look up a question roughly to what the problem you have is. You go into the textbook. There'll be a one-liner on the question. There'll be a paragraph underneath explaining in more detail what the problem is, and then there'll be one or more paragraphs underneath that explaining in detail what the issue exactly is and how to manage it if it needs managing or not. It's more a question and answer manual, so that if you have a specific problem, hopefully you can look up the particular question in the book and get a specific answer. It is roughly split into chapters. You're not looking through hundreds of questions, but it is a different format. And also the physical construction of the book, you can take it to the hive with you and open it flat on the beehive. So it is more accessible once you're at your hive if you want to take it with you. It focuses on a scientific approach to beekeeping. It's methods that JP and I have successfully used and validated as being correct and sound. The difficulty with the book was, from a writing point of view, it was intended for an international audience. My beekeeping manual was written for an Australian audience. And in itself, that was difficult because beekeeping in Melbourne and beekeeping in Queensland are quite different in many ways. And so certainly beekeeping in the Northern Hemisphere and the Southern Hemisphere are radically different. As an example, when we're talking about the honey collecting season, in Europe, say it's between maybe April and August, whereas in Australia, April to August is winter and there's hardly any beekeeping activity going on. So we have to be very careful the way we wrote answers to problems in there. Fortunately, JP lived in Belgium for a long time, so he understands European beekeeping, and I've lived in Canada and America for a long time, so I understand North American beekeeping. And also we had 2 American reviewers who went through the book in detail to point out cultural differences that we hadn't thought of. So, and also we are very, very familiar with Australian beekeeping. So it was a challenge to write, but hopefully we've successfully overcome that. Now, the difference between managed and feral colonies. It's important. There's a lot of confusion amongst the public about the difference. Managed colonies are kept in hives by beekeepers. And the top left-hand photograph shows several hives in front of a commercial truck. So these, I mean, you obviously aware this, are beehives. And so a beehive is a managed colony kept by a beekeeper. On the right photograph now is a feral colony that lives in a nest. So managed colonies are kept in hives, while feral colonies live in nests. So they're not interchangeable terms. In Australia in 2025, there were about 866,000 registered beehives. And we estimate there are probably around 1 to 2 million feral colonies in Australia. And there were about 49,000 registered beekeepers. This is an underestimate because many hobby beekeepers do not register their hives because there may be a small fee involved. They may not like the bureaucracy of registering, although it is absolutely minimal. You just go online, give your name and address and how many hives you have. And they may also feel they don't want to get it, they may feel incorrectly that one day out of the blue, a bee inspector is going to knock on the door and ask to see their hives. And that's certainly not going to happen. New South Wales has the highest numbers of beekeepers and managed colonies in Australia. So New South Wales is certainly the epicenter of beekeeping, followed by Victoria. In the bottom left-hand corner, there's a colony of bees settled under the branch of a tree. You see this quite often, or hanging on a clothesline or on your letterbox. They're only there temporarily for 1 or 2 days. What happens is a colony in a hive or a nest swarms, and swarming is a way of reproducing. Half the bees leave the colony to look for a new nest. 100 meters, 200 meters from their old colony, they collect under a branch of a tree or on a clothesline while they send out scouts looking for a new home, and then they move on. The difference between commercial and hobby beekeeping. There are approximately 46,000 hobby beekeepers in Australia, managing about 235,000 hives. There's about 1,900 commercial beekeepers managing 630,000 hives. And as a rule of thumb, there's no exact difference, but generally it's agreed that a commercial beekeeper holds more than about 50 hives and a hobby beekeeper has less than 50 hives. It's just a rough rule of thumb. Commercial beekeepers I've talked to say that if you manage about 350 hives, you can make a living from those bees for you and your family without any other kind of work. You can't live in Sydney or Melbourne with high living costs, but if you live in a rural area with about 350 colonies, you can have a basic income for you and a family. Now, in the United States, and it's moving this way in Australia, particularly with varroa destroying feral colonies, commercial beekeepers make more money for renting their colonies for pollination of commercial crops than from honey. In the almond harvest in California in February every year, a beekeeper will get in 2026 between 185 and 210 US dollars per hive to rent their colony for 3 to 4 weeks. And over this 3 to 4 weeks, 2.5 million hives will be brought to California from across North America, grossing about 500 million US dollars with a net profit of about 120 US dollars per hive just for the 3 or 4 weeks for the almonds. And it doesn't stop there. After the almonds, they take their hives to pollinate, say, oranges or watermelons or various other crops, and they get paid for that as well. They don't get 120 US dollars for that, but certainly commercial pollination is very lucrative in the United States and North America, and it's moving that way in Australia as well. So lucrative that some beekeepers in America only rent hives for pollination, and they're not interested in honey collection at all. The difference between hobby and commercial beekeeping. Many hobby beekeepers I've met who are starting out ultimately want to move into a larger organization or start up a larger organization and become a commercial beekeeper. Unfortunately, keeping bees is the easy part. After 2 or 3 years as a hobby beekeeping, new beekeepers have a very good understanding of managing bees and can easily build up the number of hives they own. The difficult part of becoming a commercial beekeeper is knowing which flowers, which eucalypts are in bloom at different times of the season, where they're in bloom across, say, Victoria, New South Wales, or Queensland, and having a place to put your hives for the 3 or 4 weeks those eucalypts are in bloom. If a landowner has, say, a field near a eucalyptus forest, they probably already rent that land to beekeepers, and they're not going to be too open to a new beekeeper coming in asking also to put his or her hives there. Also, say every November, a particular place in New South Wales, certain eucalypts have bloomed every year. You've got a plot of land there to place your hives. You go there, and the eucalypts aren't blooming this year, so you've got to move your hives somewhere else. And so you've got to have a backup plan B or a plan C. And this is a very long process to get the knowledge to do this and to get the contacts and the places to keep your hives. So it's not easy to become a commercial beekeeper, although many hobby beekeepers have successfully made the transition and are successful commercial beekeepers. And on top of what I've discussed as collecting honey from eucalypts, I mean, you also need contracts with horticulturists to pollinate their crops, and they almost certainly have existing contracts with beekeepers. I'm not going to take too kindly to a new beekeeper coming in. Now, starting beekeeping as a hobbyist, beekeeping is undoubtedly a family-friendly activity. Children with the right protective clothing, and the clothing is quite cheap. Out my experience is, and I'm sure JP's experience is as well, that children really enjoy helping, looking after bees. They put their protective clothing on. They go up to the beehive in the backyard and inspect the hives. It is a friendly activity. I've had beehives in Melbourne about 20 meters from my back door, and only once my daughter got stung when she trod barefooted on a bee. So it is quite safe. You can keep hives in many locations, in your garden, in small inner area plots, on roofs, I kept 4 or 5 hives on top of a hotel in inner city Melbourne, about 5 stories up for many years for the hotel, and that was very successful. And counterintuitively, bees usually do better in inner city areas than they do in rural areas, because in inner city, there's a lot of parks, a lot of waters, a lot of houses have flowering gardens to keep the bees going over winter. Whereas in rural areas, quite often there's a drought. The eucalypts only flower periodically. So in inner area beekeeping is actually quite straightforward. The main legal requirement is your bees must not interfere with pedestrians or neighbours. That's an absolute legal rule. That you can't, for instance, have the entrance to the hive facing through a wire mesh fence, facing next door swimming pool. You know, a bee inspector will really frown on that. So it's definitely a family-friendly activity, and the honey you collect is far tastier than commercial honey. How much does it cost to start up? In total, it'll cost between about $600 to $1,000 to start off as a beekeeper with one beehive containing hives. You might get away with a little less money if you join a club and know someone selling their equipment, getting out to the hobby. So it's not that expensive, but it is an initial outlay. This doesn't include extracting equipment. Extracting equipment is fairly expensive, between about $250 and $600. Our recommendation is not to buy extracting equipment initially. Start small. If you're near a club or a store, rent or borrow an extractor from a local club. And if you're not near a club, just manually extract the honey. I've done that for a few years. It's not any more messy than using an extractor, but after a couple of years of manually extracting, you'll decide if that hobby is for you and it's worth investing in more expensive extracting equipment. So something we tell all new beekeepers to do is they must register with the government. Now, the rules are different from state to state. If you've got generally up to 4 or 5 hives, registration is free. There's a small nominal charge for hives after that, maybe a few dollars per hive. Now, registration, we feel, is critical. You're not going to get a bee inspector knocking at your door, excuse me, unannounced one Saturday afternoon asking to see your hives. There's what they're really concerned about, as we saw when varroa entered the country a couple of years ago. Varroa was detected in one apiary near Newcastle, New South Wales, and the bee inspectors needed very quickly, within a matter of days, to mobilise to inspect all the apiaries in the vicinity of that infested apiary. So they needed to know who in the area and in the wider New South Wales had bees, so to quickly go and audit their hives to see how far the mite had spread. That's the main reason they want to know who's got hives in the district. So we feel registering is a must activity for a new beekeeper. And the other thing we recommend is new beekeepers join a club. There are many, if you live near an urban area, there are many good in-person beekeeping clubs around that are very helpful to new beekeepers. And if you're not near a club, not near an urban area, there are very many online clubs like the one JP formed, Melbourne Beekeeping, that has members all across Europe and also liaise with North American beekeepers as well. So there's a lot of support available no matter where you are. Now, one of the issues with beekeeping is, excuse me, I mentioned that public safety is important, that your bees don't sting anyone. A lot of neighbours don't take too kindly to you having a beehive in your backyard. So if a neighbour complains with your bees to a government inspector will come around to look at your situation. The first thing he or she will ask is, are you registered? And if you're not registered, they're going to come down on you like a ton of bricks. They'll give you 2 or 3 weeks to get rid of your hives completely. No questions asked. And if you haven't got rid of them, they'll fine you. Okay? So you must register. If you are registered, they look at where your bees are and so on. If your bees are not next to the fence disturbing next door, they're in quite a decent position and they're well managed, they'll be on your side. They'll go to your next door neighbour and calm things down, say you're managing your bees very well, that you're following all the legal rules, and they're very happy with the way you keep the bees. So they are in times of conflict with neighbours, which happens occasionally, not that often. A bee inspector will be on your side. There are different designs of beehives. On the very left, there's a long straw hive, which is used almost exclusively by commercial beekeepers, not only in Australia, but in North America and Europe and other parts of the world. The parts of it are widely available online and in stores. The difficult part for a hobby beekeeper is the bee's nest is in the bottom box, and the top box is where they store honey. And if there's a lot of honey coming in, those top boxes can weigh 40 or 50 kilograms each. So if you're not that strong or you have some physical disability, they can be heavy to manage. The second hive along, the so-called horizontal hive, sometimes called a coffin hive, where all the bees and honeys at one level, that you just remove the lid, it may be hinged, and the frames the bees live off are very accessible. At one end will be the bees, at the other end will be where they store all the honey. So it's a very accessible type of beehive. A bit more harder to buy those horizontal hives, but they are available online and in the larger beekeeping shops. The third one is another design of the long straw hive. There are different designs of long straw hives. Notice the lid is a bit different on this one. The advantage of the different lid is in very hot climates, you can put insulation in there. So it is a bit different. And it's more an American design, the third one, compared to the long straws on the far left. The more beekeeping traditionally is very conservative, and the introduction of the flow hive on the very right, designed, as you know, by a father-son pair in Queensland a few years ago, has really shaken up the way hobby beekeeping store and extract honey. The way the bees live in the bottom is the same, but the way honey is extracted and stored is very different. And this is now a very popular way of keeping bees in your backyard. It has become very popular all across North America, Europe, and Australia. And I'd recommend looking at that as a way. So the problem with each of these 4 hives is the entrance to the hive is at ground level. So bees coming in and out are a risk to people walking by. So if you look on the very right now, there's the so-called chimney hive, which JP designed and built and is kept at Melbourne University. The beehive is at the back, and that's at waist height. So it's very easy to take the lid off and look inside the hive at the honey and at the bees. But the entrance to the hive is 3 meters off the ground up the top of the chimney. So there's minimal risk to passers-by getting stung by bees entering and leaving the hive. Bees themselves don't mind going up and down the chimney. That's no issue for them. So this is quite a popular design if you want to demonstrate bees, say, in a school or in a public area. It's very popular, and JP uses that a lot for training and teaching, and it was right next to a path that students use frequently all day at university without any problem that I'm aware of. Finally, types of honey. This is probably the most confusing part to the average person. Supermarkets tend to have a uniform taste, very bland honey. It's a blend of different types of honeys. Premium honeys, say like the eucalyptus, orange, yellow box, are expensive. Whereas inexpensive honey like canola, of which there's a lot of canola honey out there, doesn't taste that nice. There's nothing wrong with it from a health point of view. It just doesn't have the premium taste that the eucalyptus does. So what the big honey packers do, a packer is a commercial organization that collects honey from beekeepers and bottles it. So what the honey packers do is they blend high quality honey with inexpensive honey like canola and makes a sort of average tasting honey that's quite expensive. But it's the popular honeys, the orange eucalyptus, that taste nice, but it's unlikely you'll find those in many supermarkets. Another thing that confuses a lot of people is the difference between liquid and crystallized honey. Honey is a mixture, very approximately 50-50%, of the two sugars, fructose and glucose. And the mixture varies from the flower the honey comes from. Honey that's high in fructose, and fructose is very soluble, the honey will remain liquid. If the honey is high in glucose, and glucose is not that soluble in water, the honey over time will crystallize out. There's a perception amongst many people that honey that crystallizes out isn't that good a honey, or it's been adulterated, and that is far from correct. In my opinion, glucose is far better for you than fructose, fruit sugar. You're better off having honey with more glucose in than more fructose in. So you're better off having honey that crystallizes. If it does crystallize, it's easy to liquefy it again by placing it in a pot of hot water, and over time the honey will liquefy again without any deterioration in the quality of the honey. There's another issue with adulterated honey. In developing countries in particular, honey is often mixed with sugar or other types of sugar, high fructose corn syrup, because they're very cheap compared to honey. It's sold as pure honey, but they are adulterated. Health-wise, there's not anything wrong with them, but they're not pure honey. And people feel that crystallized honey has been adulterated. If a honey is adulterated, it won't crystallize because the sugar they put in is very soluble and won't crystallize out. So this needs better education towards the general public. Okay, so that's all I have to add. So thank you very much for listening to my part of this. I will now pass you over to JP to talk about pollination and varroa. Stop sharing. Okay.
Okay, thank you very much. Now, Jennifer, how much time do I have?
We're about halfway through. So
okay, that's good. That's good.
Yes.
So I'll try to go a little bit faster and then allow some time for questions. So thank you very much. So I'm going to talk about pollination, and then I'm going to talk also about varroa and how varroa affects or will likely affect pollination. Here you can see on this picture, this is an almond plantation, and you can see that there's quite a lot of hives that have been brought there to pollinate this particular crop. And those, referring back to Robert's presentation, those hives have been moved there for the purpose of pollination by professional beekeepers, by commercial beekeepers. Typically, hobbyists will not move their hives. They will stay at the same spot. And while they are very beneficial for the gardens around them, they do not contribute to the pollination of large-scale crops as opposed to the commercial beekeepers. Now, one of the questions we can ask is, well, why do we actually need European honeybees to pollinate our crops? Australia has done very well for a very long period of time, hundreds of thousands of years, without any European honeybees. They were, after all, brought in after the colonization of Australia, and the first European honeybees were brought in very quickly by the first settlers, who realized that it would be beneficial to have pollinators. And this area here shows very clearly, or those two pictures show very clearly what would happen in the absence of bees. So on the left, you have a typical supermarket, and on the right, you would have the same supermarket without, where all the produce that is pollinated by bees has been removed. So you can see lots of apples being removed, avocados, plums, and so on. So there's a lot of different fruits and vegetables that are pollinated by bees. In particular, all of the nuts are very require bees, and most of the fruits and vegetables. In fact, 2/3 of the different species of plants that we eat are pollinated by bees, and in volume, it's about 1/3 of the food that we eat. Now, in Australia, we actually have a lot of native bee species, and we have over 2,000 species of bees in Australia. Some of them actually still poorly characterized or even unnamed. And there's a couple of bees here that have been shown. The problem with a lot of those bees is that they are not colony forming. The sugarback bee here at the bottom is a colony forming bee, but it's a bee that only comes in tropical climates. So north of Sydney and north of that, you will find those ones, but in the colder parts of Australia, you only find bees such as the blue-banded bees, the teddy bear bee, the carpenter bees. All are bees that do not form colonies. Now, why would we need to actually rely on the managed bees for our crops? And the reason is that the crops that we grow now are grown in large, extensive systems and large agricultural systems. And for example, here a canola field, for a couple of weeks a year, this is a great place for bees to be. But for the other 11 months, it's an absolute desert when it comes to bees. And in particular, the native species of bees can't travel very far. They will only fly a couple of 100 meters at a time. And therefore, they cannot possibly survive in a canola field like that, which means that every year you have to bring the new bees into this canola field to get them pollinated, and you cannot rely on those native bees to do that. And just as an example, the almond trade is a typical situation, maybe the most extreme situation in Australia. So the almond trade, as you can see from this highly distorted view of the world here, which represents the production of almonds by different continents. And you can see that North America, particularly California, produces an enormous amount of the almonds. About 90% of all the almonds produced or exported are produced in California. So 90% of the traded almonds on the world market come from this one region here. Australia produces quite a lot of almonds because you need a dry, hot spring and summer. You need a cold winter and an enormous amount of water. And the almonds are 100% dependent on pollination by bees. Even the so-called newer varieties that are less bee dependent, they still require bees for their pollination, although less so than the traditional varieties. So large plantations require the right conditions. And of course, in some parts of Australia, we have that. and they require lots of bees and lots of water. The other thing that is worthwhile mentioning is that we're growing a lot of almonds, and this is tons produced. So we have over 160,000 tons of almonds are produced in the last year. That's an estimate. And from this graph, you can actually see that it's increasing dramatically from, even in the last 10 years. And if you go further back, there is almost an exponential growth of almonds production. There is only here in 2023, that season was pretty bad, and that's the season that was where we had a problem with varroa. Varroa was introduced in 2022, and in 2023, in an effort to limit the spread, migration of beehives was prohibited between New South Wales and other states, and the result of that was a dramatic reduction in the production of almonds. Now, almonds need to be pollinated in August every year, and you need about 300,000 hives to do that job, and they come from all over the place. So hives will be moved from southern Queensland all the way to Victoria, South Australia, 2,000 kilometers. And if you think about it as having 100 hives per truck, you will need about 3,000 trucks to do the job. So it's an enormous logistical nightmare to move all those hives around. Now, one of the problems with that is, of course, biosecurity. You bring all those bees together for a period of about a month, and then they go back to where they came from. And during that time, you can, of course, predict that all of those hives sitting close together will exchange diseases, and particularly varroa mites in this case. And that's the reason why in 2023, we were not, the production was reduced, because migration of beehives was highly regulated. So this leads me to a concept which I call the pollination bottlenecks. And those are locations and seasons where most of the hives are required for pollination of particular crops. And as we have seen from our previous slides, for the eastern region, and in Australia, we can really distinguish 4 distinct pollination regions. And they are based on the fact that you are not allowed to, either you're not allowed to, or it is not practical to move hives between regions. So we have an eastern region, essentially going from South Australia, Victoria, New South Wales, Queensland, so the eastern part of Australia, and there is free movement of hives between those regions. Then we have Western Australia, and Western Australia is, for biosecurity reasons, they don't have European foul brood, and because of that, there's an absolute ban on movement, not only of bees, but also of honey and other things from other states or from other areas into Western Australia, which means that once you move hives, you're allowed to move hives out of Western Australia, but once they have moved out, you can never put them back in. The Northern Territories, it's quite different there, in the sense that the restriction is not a biosecurity issue, but rather a distance issue. Moving hives over those type of distances is not really practical. And Tasmania is a biosecurity issue. They don't have small hive beetle, and they definitely don't want it here either. And of course, they don't have varroa either. So taking that into account, those 4 regions can each have a particular bottleneck. The eastern region is the almonds in August. In Western Australia, it's mostly the avocado and some broad acre seeds, such as canola seeds or seeds that are grown there in large scales. In the Northern Territory, the beekeeping industry is actually very, very small, and with only, I don't know, maybe 100 or less than 100 professional beekeepers in the Northern Territory. And mango is really, in May, is really one of their key crops. And Tasmania actually has 2 different times where there is a bottleneck. one bottleneck is between the vegetable seeds and the requirements for actually producing those seeds require the presence of bees. And for example, carrots, the carrot seeds, as in this picture here above, requires the presence of bees, and that competes with the leatherwood honey. And Robert has talked about the specialty honeys. Well, one of the specialty honeys that is produced exclusively in Tasmania and is very highly priced is leatherwood honey. The flower is on the right here, and there's a direct competition between the production of leatherwood honey and vegetable seeds. Beside this period, the other period is October, where a lot of the other crops, particularly the stone fruits, are being pollinated. So cherries and plums and those types of fruits, and also apples and pears. So sometimes there is a competition between specialty honey production and pollination. And Robert has actually mentioned that in the US, a lot of the beekeepers are focusing on pollination rather than honey production, because it is possible and actually quite easy and cheap to import honey, but you absolutely need to have the local bees to do the pollination. So if you have to choose between one or the other, then pollination generally wins out, with the exception of very specific honey that is local, such as the leatherwood honey. Now, those pollination bottlenecks are important, particularly for horticulturalists, because if there is going to be a shortage of hives, then they will affect those bottlenecks more than anything else. So if your crop happens, for example, your crop in the eastern regions need to be pollinated in September or October, then it's not really a problem, because there's going to be enough hives to pollinate those. And the bottleneck will happen only in August for the almonds. So knowing where your crop or when your crop needs to be pollinated, in which region, and whether you're going to have to compete with those very big crops is going to be very important. In particular, when there is a restriction on either movement of hives or just not enough hives available to pollinate all the crops, for example, due to the impact of varroa mite. So that sort of brings me to the second part of the talk, which is about crop pollination and the impact of varroa. I'll just start by saying a couple of things about the varroa biology, because it's important for the understanding of the rest. So varroa is a parasite that lives inside the hives and has a very specific life cycle. It starts off with a fertile female mite going into the hive and laying the first egg that she will lay. Is always a male egg, and then she lays another 3 eggs afterwards on subsequent days. So 1 a day for the first couple of days after she enters the cell. This first egg will mature and give rise to a mature male mite, and the second and third and fourth eggs will start to mature slowly, and in a worker brood they will be able to the male mite will mate with his female sister within this same cell, and then a day or two later will emerge together with the bee. This is a very slow process, because you start effectively with 1 fertile female mite, and at the end of this cycle, you end up with 2. The original one, which is still alive, and a second one that has been mated. So it's a very slow process. And the result is that if you model it, is that the accumulation of mites in the hive is extremely slow. And I will not go through the details of this model. This is part of Robert's PhD thesis. But the take-home message of this slide is really that if you were to put a single varroa mite on the 1st of July into a hive, then it would take almost a full year, about 10 months or so, before you are able to detect this and have a significant number of mites within this hive. So the cycle is so slow that it will take a very long time, and it will take up to 2 years after this single mite enters the hive for the hive to completely collapse. Now, it will always collapse if you don't do anything about it, because it will be eventually the mite always wins, but it takes a long time, which means that it's very difficult to detect, especially in the early stages. You essentially have a period of 8 months where the hive is infected, but it's impossible to know that it is infected, and you don't see anything on the bees, you don't see any abnormal thing to the hive, and suddenly you will be able to detect it, and a couple of months later, the hive will invariably die from this condition. Now, the implication is first that once your hive is infected, it's very difficult to, or once a region gets infected, it's very difficult to prevent the further infection of hives. The second implication is that the feral hives, so the ones that are not managed by beekeepers, they will form a reservoir for the mites. So they will be infected over and over again. Eventually they will die out, but it will take several years. And during that period, the mite will sit there and be able to reinfect your hives even if you treat them. So control becomes very difficult, and that's why once you have an established mite population, no country in the world has managed to eradicate it completely. Another implication is that the feral honeybee population, so the ones that are not managed, and we are talking about European honeybees that are unmanaged in trees, for example, in tree hollows, they will invariably disappear about 5 years or within 5 years of the introduction of varroa. And faster if you have a presence of other diseases which are associated with varroa, such as deformed wing virus. And deformed wing virus is a virus that is transmitted by the varroa mite. I don't think I'll talk about Tropilelaps at the moment. So one of the things that that was part of this pollination security status report that just came out is that we have indeed 4 regions, as discussed earlier: the eastern region, Western Australia, Tasmania, and the Northern Territory. At the moment, only one of those regions is affected by varroa mite. There is no varroa mite in Western Australia, Tasmania, or the Northern Territory, as far as we can tell. Of course, from a horticultural perspective, the eastern region is really a very important one, unfortunately. The impact, and we know a lot about that because, of course, every other country in the world has had to deal with varroa mite at some stage. We were the last country to actually have varroa, so we have the benefit of having learned what other people have done in other parts of the world. And of course, our close neighbors in New Zealand are a good case study for what is likely to happen to us. And they first got varroa about 20 years earlier. So we are 20 years behind New Zealand when it comes to varroa. The impact on beekeepers will be that there will be a massive cost increase, not only because they have to now treat the hives, and that's a cost in terms of labor, in terms of chemicals use, in terms of losing some of the hives. As a result of that, many beekeepers, particularly more older beekeepers, will give up beekeeping, and that's true for both hobbyists and commercial beekeepers. The industry, the commercial beekeepers, will often consolidate, so the larger beekeeping operations will manage to absorb those cost increases and become more efficient, and they will buy up smaller operators. Overall, we can expect a dramatically fewer hives, at least initially. And depending on the country, that period lasts between 5 to 10 years for the number of hives to come back up after the consolidation of the industry. From a perspective of the horticulturalists, and particularly the small operators that are using small plots, and when small plots I mean less than let's say 10 acres or so, then the loss of feral hives will be very important. Many small orchards or small gardens, and that includes gardens in the cities or personal gardens, rely really on those feral hives, on those feral bees for their pollination. They don't own a hive, they don't have hives close by, and they just rely on European honeybees that are living in the environment for their pollination. Those ones will disappear within 5 years of varroa moving to the particular area, and especially during the pollination bottleneck where other crops need to be pollinated, that will have a major impact. And so small operators might want to start keeping bees themselves and managing bees so that they have access to their to bees for their pollination. And again, we can't really rely on the 2,000 odd native Australian bees to do the job. There's just not enough of them to pollinate all of the crops that we are growing in Australia. So I'll stop here and allow some questions, and we can do questions to both Robert and myself. Thank you very much.
Thank you, JP, and Robert as well. That was really fantastic. Now, does anyone have a question? If they'd like to unmute themselves to put a question forward, now's the time to do that.
Yes, Connie?
I have a question. Thank you so much. I've always been interested in keeping bees. I wanted to ask, so are you saying in the future varroa mite will wipe out all feral nests over time? And
yes,
so
that's been the experience overseas, indeed.
So there's a greater increased kind of importance in having more kept hives.
Yes, because the beekeepers will actually treat their hives and prevent them from dying out. And in particular, in the early phase, that's very important because, as I sort of mentioned, the feral hives are not treated. You can't go and identify a hive in a tree trunk and then start treating it. That's not practical. Now, eventually that hive will die out, but before it dies out, it will have a very high number of mites inside, and then finally it will die. And as soon as that happens, there's a lot of the bees from other parts will go and raid that hive and steal all the honey, and in the process they will carry the mite back to their own hive. So initially it's going to be actually, and it has been the experience overseas, that it's very difficult to keep bees for the first 5 to 10 years after hives have been infected, and then after that things stabilize a little, and the surviving hives are all the managed hives, and they have low mite counts because the beekeepers keep them that way.
So as in the first 5-10 years is more difficult because of all the feral nests being infected, and then once they all die out, it stabilizes.
Yes, indeed.
Okay.
That's sort of the situation. And then longer term, and of course some parts of the world have had varroa for a very long period of time. I mean, varroa actually started to become a problem in the 1950s. And that's a different story altogether. But so in some parts of the world, we have had varroa for 70 years. And in those parts of the world, genetically adapted bees, so bees that have been selected over decades, have now developed resistance, genetic resistance to varroa mite. And they are around there. And once that happens, then very slowly feral hives appear again of those genetically enhanced or selected hives. And it's a natural phenomenon. People don't interfere with it. It just happens over a period of time. If you have a hive that becomes resistant, then suddenly they have an advantage, and they start to reproduce in the wild.
Yeah, got it. Thank you.
Okay, Steve.
Yeah.
Thanks, Connie.
Yeah.
Any questions? Yep, Steve.
Oh, sorry. Yeah, look, really interesting talk. I got a couple of questions. I think you've resolved one of them about why the bees themselves didn't have an immunity given their experience with it. Presumably there were species that did have immunity, and then they were transported to the UK or something. Is that how it started?
No, so initially the varroa mite is actually a parasite of another species of bee, Apis cerana, as opposed to Apis mellifera, which is the European honeybee. It was a parasite of the Asian honeybee, and those populations were quite separate. And then somewhere, and they don't know exactly where, but somewhere in northern China or southern Siberia, the two populations actually of those bees for the first time interacted with each other. And they moved because beekeepers in northern China started to keep European honeybees. And that's when the mite jumped from one species, from the Asian honeybee to the European honeybee, and then slowly but surely through the Trans-Siberian train were transported over quite a few years to Europe, and then it started spreading from there. So that's how varroa became widespread. Now, in terms of resistance occurred in different parts of the world quite independently. So yes, there are European resistant strains, there are US and Canadian resistant strains, and there are African resistant strains, and the mechanism of their resistance is quite different depending on how they emerge. So some of them are behavioral, some of them different types of resistance has emerged independently in different parts of the world.
Very interesting. So another question then is, in terms of detection, I'm just wondering, because we're using it up here, I'm using it in streams, etc., do genomic testing for looking for various species that are in that habitat by doing genomic testing of the water. Is it possible then, given the two-year period, that the problem being that, it takes that long before it becomes obvious that you had the infection, would it not be possible to do genomic testing of the hives, which is getting relatively cheap, and therefore know in advance?
Yes, Robert, do you want to talk about that, or you want me to? Because I've been talking too much here.
Yeah. If I understood the question correctly, from a bit hard of hearing, we're not quite certain which genes or all the genes are involved in resistance. And as JP said, there are several different ways, behavioral and resistance to the mite, that are involved in being resistant to varroa. So just because one population, say in America, is resistant, a population in Europe could be resistant in a totally different way, that are completely unrelated. So to do comprehensive testing is impractical, and it's not possible now. And that's one of the big mysteries of varroa, is to identify all the genes involved in the different kinds of resistance.
I see.
We're getting a little bit more specialized here, but one thing that we know is that it's definitely not a single gene effect. It's a behavioral, and so it's a wide range of different genes that are involved in changing the behavior of the and the biology of the honeybee. For example, so one of the most well-known methods of being resistant is the hygienic bees, which are the ability to detect whether the varroa mite is inside the cell, and then effectively chew out this capped cell and take out the unborn bee before the mite has a chance to mature. Now, if you think about a behavior like that, that requires a whole set of different genes to detect that it's infected, to start chewing, to take the thing out, and so on. And so the genetics is poorly characterized of those resistance methods.
Right, I see. What about the early detection of the mite itself by genomic testing? In other words, like taking samples from the nest and therefore, or the hive, therefore you could be aware of its presence.
You could. The problem is the sheer number of hives that are present. I mean, we are talking about 850,000 hives, that would need to be tested regularly. And yes, you would be able to detect it more easily. Now, once varroa is present in a particular region, essentially, most hives will have some level of varroa in them at all times. And it's a matter of keeping it in check. It's only very important to have an early detection if you are able to if you attempt to eradicate it in a particular area. Once it's established, let's say New South Wales, it's there, it's almost everywhere. Most hives will have it. It's a question then of finding, of preventing the hives from dying by detecting it before it's a problem. And
right, I see.
Just
so it's an assumption.
The sugar shake and the alcohol wash can do that perfectly well.
Okay.
And if I can add a bit here, one of the issues of migratory beekeeping by commercial beekeepers is they're transporting their hives like every few weeks all across Eastern Australia. I mean, I think we're going to see it spread very rapidly across Eastern Australia. So if an area doesn't have it now, I mean, they soon will. In America, it spread rapidly.
That's a bit sad. What about native bees? And a final question, because I've been keeping native bees for about 20 years. I use them for my pollination. Why is it, I've heard the story, and I don't know if it's true, that because native bees don't encapsulate their larvae, the varroa mite can't get a hold. Do you know, can you throw some light on that for me?
Yes, so native bees are generally unaffected by varroa. It's only the two species, Apis cerana and Apis mellifera, so the European honeybee and the Asian honeybee, that are affected by varroa. And the Asian honeybee, because it has evolved over a long period of time with varroa, actually doesn't die out from varroa. Now, the biology of the mite is very, very specific and very intricately linked to the biology of the European honeybee. And of course, so if you even have a day or two, the life cycle is only a day or two shorter, then the varroa cannot take hold of the in a hive. It needs to be exactly the right timing, the right size of cell. So it's really very specific for one particular species. So fortunately, it's very unlikely that it will affect any of the 2,000 species of honeybees that are present in Australia.
Mm.
Thank you very much. That was very informative. Thank you.
Okay, Helen?
I think Helen's got a question, yes.
Hi. Thank you both for your most interesting presentations. So how much is varroa mite impacting the desire or ability of home hobby beekeepers to get into beekeeping? Is it scaring them off, or is it, is managing varroa mite in a hive within the capacity of sort of your average home enthusiast?
If you look at other countries, say like Germany, when varroa was first introduced, the number of hobby beekeepers decreased quite significantly, or in New Zealand. But managing varroa is extra work. But once the sort of, I'll say, the cultural knowledge of how to manage it is in the beekeeping community, there's a big rebound of the number of hobby beekeepers. It is more work initially. The trouble is there's not much experience with it in the beekeeping community and hobbyists. But once it becomes more widespread and knowledge about management, it becomes quite straightforward. It's a matter of testing your colonies for varroa, which takes about, time you leave your back door to walking back into your back door, maybe take half an hour or so. And then if the mite is large, or there are large numbers of mites, putting miticide strips in. Unfortunately, a lot of treatment now does revolve around miticides, which are harmful, which I don't like, but we just have to live with that until more resistant bees are developed. So it is manageable. The problem is you can't ask many people because not many people have experience with it.
Any other question, Helen, or does that answer your question?
No, that does answer my question. Thank you. And I guess it's a matter of, the various clubs, getting more experience and then ramping up their education amongst their members.
Yes. And of course, now Australia has done a very good job at actually educating beekeepers. The government actually put beekeeping education programs in place. Now that's now one down, but those things have been happening in the last 12 months or so, quite significantly. So every beekeeping club will have at least some members that have participated in those training sessions. And as Robert said, we were the last country in the world of having varroa. So everybody else, everywhere else in the world is managing varroa. And so, yes, it's feasible. It's just a lot more work. And it's a matter of getting used to it, and also to overcome this 5-year period where you can expect that your hive is going to be infected again and again and again, because the feral hives will bring in new mites into your hive, even if you treat them. While once they disappear, then you don't have that. And it's, essentially, if your bees are free of varroa or as a low count of varroa, then they will remain like that for a longer period of time without getting reinfected again and again.
Interesting. Are there any other questions? Otherwise, I think we've gone well over time, and we probably need to let our guests go. Any more questions? Or Judy, can I ask you to thank our speakers?
Absolutely. Actually, I was wondering if this might lead to a revival of our native bees. It must have been Armageddon when the European bees came in, so maybe their populations might increase a little bit.
There is an interesting debate among the scientific community about the impact of introduction of European honeybees on the native bee population, and in some states in Australia, national parks can have hives, so you're allowed to bring hives in national parks. In other parts, it is that's not allowed, and it's a hotly debated issue, because of course beekeepers, particularly commercial beekeepers, would love to get unfettered access to those floral resources in our national parks.
In the national park.
And so there's a hot debate there of what the problem actually is, and what the impact is, and not an easy thing to ascertain, particularly because not even all of our native bees have been categorized. I mean, there's about, I think, 1,200 or 1,300 native bees that have been documented, and then there is another 700 or 800 that nobody has even given a name to.
All right. Well, look, I mean, I think just we're all so grateful to you both, holding you up, sharing that expertise, giving us perhaps a bit of despair and a bit of hope as well. So thank you very much. Look forward to seeing the book, and on behalf of all of us, and we know that the other people who watch the video, watch the presentation afterwards on our website, will also get as much out of it as we did. So thank you very much, both of you.
Thank you, Jennifer, Judy and George, for arranging this. and for everybody listening. It was our pleasure, certainly mine, to talk with you
Thank
today.
you.
Yep.
Okay,
Can I
thank you.
just add a
Bye.
plug? No, it's reversed, but really do get hold of the book, Beekeeping Success. It's excellent. So look for that. And the other thing I just want to say before we all finish is that our next webinar will be on the 25th of September at 12 noon with Paul West and Daryl Nichols, and it's about Grow It Local. So you'll get information about that through the emails and the website. Thank you everyone for attending.
Thank
Okay.
you.
Thank you,
Bye for
Jennifer.
now. You can stop recording, George.